Hello everyone and welcome to another video with Mr. Math. Today we're talking about integration techniques and specific about completing the square. Okay, we have the integral from -3 to -1 of 1 over the square root of 7 minus x squared minus 6x dx. As you can see, there's no u du substitution possibility because the derivative of that x squared is going to be 2x and we don't have that on the numerator, so there's nothing that we can truly do with that expression. But the technique here is going to be working with our denominator. So let's first reorganize and work with what is inside the square root. We're going to manipulate that polynomial, okay? So we're going to have negative x squared minus 6x plus 7. So I'm going to pull out a negative outside of the parentheses, and I have x squared plus 6x minus 7. Remember, in order to complete the perfect square, we're going to take the middle term, divide by 2, and elevate to the square. 6 divided by 2 is 3, divided by and elevated to the square, that will be 9. So I have negative 7, and I need to build a 9. So my options there are going to be, to this negative 7, I am going to need to add 16 and then subtract 16. If I add 16 and subtract 16, nothing has happened. But this negative 7 plus 16 will make the 9 that I'm looking for. So I'll have negative x squared plus 6x, negative 7 plus 16, that will be 9 minus 16. Now, this specific part, that trinomial there, is actually a perfect square. So we'll have negative x plus 3 to the square. Let's make that 3 better. X plus 3 to the square minus 16. And notice that this, I'm going to change the color of this one. Notice that that negative is affecting the entire parenthesis, right? So I'm going to utilize that negative and I will reorganize my expression. That will be 16 minus x plus 3 to the square. With that information, I'm going to rewrite my integral over here. Okay, I'll have the integral from -3 to -1 of 1 over the square root of 16 minus x plus 3 to the square. And this will be dx. Okay. Now we could apply a u du substitution here. Okay, let's work on that. We have a u equals to x plus 3, and our du now is only dx, so it's going to work perfect. Now we still need to work on what are our new limits of integration. So we're going to have u of -3 and u of -1. Okay, the u of -3 will be just 0, and u of -1 will be 2. So our new integral will be the integral from 0 to 2 of what? Of 1 over the square root of 16 minus x plus 3, we know that is u, so it will be u squared du. Okay, now once again we're going to bring the shapes of the integrals of specific functions that turn into inverse trigonometric functions. Okay, so let's see that one and see which one matches with it. Okay, so we have on the denominator square root, and we have an expression, a constant minus u squared. So it looks like the first option, the one that is going to turn into the arc cosine. It turns like this is our option, but we still need to express that 16 as something to the square. Now that's going to be simple. So we're going to have the integral from 0 to 2 of 1 over the square root of 4 to the square minus u squared du. And now it looks exactly the same. So according to our expression, this is equivalent to the arc sine of u over a, u over 4, and this will be evaluated from 0 to 2. Remember, we don't need to use the constant of integration because this is a definite integral. Okay, now we're going to solve the limits here. So we're going to have the arc sine of 2 over 4, which is 1/2, minus the arc sine, in this case, will be 0 over 4, which will be 0. Okay, so the arc sine of 0 is just 0, and the arc sine of 1/2 is pi over 6. And that should be our answer. Thank you for watching. I hope this video is helpful for you.